Chapter 1, Lesson 6 of Pre-Calculus, we're going to look at graphical transformation. Much of this information is what we covered last year, so we will move quickly, but we will also go a little bit deeper and talk about some things that we did not cover last year. So we'll look at vertical and horizontal translations first, then we'll look at reflecting these items across the axes, and then we'll look at vertical and horizontal stretches and shrinks. So vertical and horizontal translations, you remember, are moving horizontally. We're moving the graph to the right or to the left. And if C is the shift, in other words, if C is the number of units that we're moving to the right or left, the way that shows up in the equation is we replace the x in the equation with x minus c, where c is the number of units to the right or to the left that you're moving the graph. The vertical translation is if c is the shift, again, you replace y with y minus c. Now, the y value is on the left side of the equation, so usually what we do is we end up having the equation solved for y, so this shift shows up on the other side of the equation and looks to be not subtracting from the transformation from the equation, but rather adding it. And the reason that is because it's on the left to begin with, because that's where y is, but when we move it to the other side by adding the opposite, it looks a little bit different than maybe the horizontal translation, but actually we're doing the same thing. And I'll give you an example or two in a moment and you'll see what I mean. So let's take the function f of x, which here is x squared, and we're going to move this x squared graph to the right 2 and down 3. So in order to move it to the right 2, that's a horizontal shift, we're going to replace x with x minus, and then we're going to put the shift here. So it's 2 to the right. Right is positive when we go to the right on the number line. So this is a positive 2, so I simply put in 2 or substitute in 2 for c here. Now with the vertical shift, we're replacing the shift down 3. So the shift is down, so that's negative 3. So we're going to replace the y with y minus, and then we're going to put in this negative 3. So it's going to be the y minus the negative 3 shift, or down 3 shift, and then over here we substitute in the x minus 2 for the horizontal shift. Now these two negative signs, you'll notice, will become positive when we simplify that, and then we're going to need to solve this equation then for y again. So we move the 3 to the other side, and now it becomes negative again. So you'll see the horizontal shift appears to be the opposite of what I see. In other words, I see a negative 2 here, and the shift is actually to the right. Here I see the shift looks to be a negative 3 down, and it is. So while the x appears to be the opposite of what I see, and the y appears to be exactly what I see, the only difference is this was originally over here. And if you looked at it while it was over here, you would see, well, this isn't a shift up 3, it's actually the opposite of what I see. This would be down 3. So the reason that the x looked opposite last year and the y looked exactly what it appeared was because we were actually skipping this step right here, where we would not put the c in on this side and then solve it. We would simply put it on the other side, knowing that that's how it was going to end up. So hopefully that explains why those things appear to be different, when in actuality they're actually the same. We're just subtracting the shift, one from the x for the horizontal and one from the y for the vertical. So a few examples here. Here we want you to describe how the graph of f of x is equal to x squared could be transformed to the graph of this given equation. In other words, I'm going to give you an equation that has adjusted this x squared. What's the shift? So here's the first one. If I have the equation x plus 50 squared minus 279, how is that a shift of this original function x squared? Well, inside here is going to be the horizontal shift, and it's going to be the opposite of what I see because it's x minus the shift. So if you think about it, it's x minus the shift. Alright, well, how does this become positive? Well, the only way to get that positive is for this to be a negative 50, and I wrote that way too small, so it looks kind of scrunched. So let me do this a little bit bigger. So x minus the shift. Well, the only way for this to be a positive is if the shift is a negative. So that's where I get the shift down. And then here I see what the shift is because this was on the other side. We've already taken care of the sign, so this would be down 279. Now I think I said this was a shift down, but that should be a shift to the left 50 units, right? Because it's negative and negative goes to the left. So left down and then a shift, or I said it again, left 50 and then down by 279. Okay, so let's do one more or so. So here the x squared again has not been changed, so this is not a shift right or left. This would be a shift down 100. All right, and I want to pull these through very quickly. So this would be a shift to the left 4, right, because it's the opposite of what it looks like. Do one more here, and then this would be down 3. It's a vertical shift, so it's exactly what I see, so it would be down 3. Okay, so I hope that refreshes your memory what we did last year, and also kind of explains why they end up looking different when actually they are the same.